السلام عليكم ورحمة الله. وياكم عباس علاء، أحد أعضاء SPE بصل ستودنت شابتر. أهلا وسهلا بكل الحضور الكرام، حضور فرعنا الطلابي. نلتقي اليوم بمحاضرة جديدة ومميزة، تكملة لمحاضرة يوم أمس بعنوان Drilling Fluid. يقدمها المهندس إبراهيم المعمري، المهندس الميداني في شركة KCA في عمان، بخبرة تتجاوز 7 سنوات في مجال النفط والغاز والطاقة المتجددة، إضافة إلى قيادته لفرق هندسية مع خبرة واسعة، وحاصل على شهادات مهنية مثل IWCF Level 4. ونرحب بمحاضرنا الكريم. أهلا وسهلا بك أستاذ، إذا تقدر تتفضل.
Thank you everyone. And we will continue our session from yesterday about drilling fluid, and I hope you guys who attended yesterday learned something new and they can apply it in their academic life. So yesterday, if we recap about what we said, we learned about the history of using drilling fluids. Then we learned the functions of drilling fluids. Also, we learned about separation equipment that separate drilling fluids. What we did yesterday is overview for the whole subject, and what we're going today to do is going much deeper in that subject. I'm trying to not to go very technical, so you don't forget, but at any time if you have any doubt, you can just stop me and ask me, if you cannot ask me in English, you can do it in Arabic. So I prepared some slides for today, and we will go through them to help me explain the subject for you guys. We discussed drilling fluids, and we said there are 3 types, but mainly we're going to talk about 2 types of them, and which are water-based and oil-based drilling fluids. And the design, when they design drilling sections, because we know drilling go through sections, and so once you for example you drill 16-inch hole, you run 1338 casing, then you go to the other section 12-quarter, then you will run 958 casing, and then you will drill 8.5 and you run 7-inch casing. All these separations, one of the main things they are trying to do is separate by mud weight, because each formation has its specific mud weight. For example, if you have a mud weight of 14 drilling in the 16-inch, and you have the next section is 8, you will frack if you combine these sections. So this is one of the things why we separate when we are designing well, why we separate it to 2 sections, as well as what type of drilling fluid. Some sections we can drill them by water because we don't have reactive shale, and some sections we require to have an oil-based mud because it's very reactive. Some sections are theft zone, some sections are hard zone. This is all are implemented when you are designing drilling fluids. So we will talk about mainly water-based today, and through talking about the water-based, I will try to compare to the oil-based in the whole the slides. So we will learn about water-based fluid definitions, water-based fluid system, the family for water-based fluids, the water-based properties, and the typical water-based and their additive. So water base, the base for the fluids is water. It's very simple. And water can be fresh water, and what we mean about fresh water, it's similar to what drinking water. It has a low chloride. It has a low chloride percentage in that water. That's they call it fresh water. So, for example, in cementing we use a fresh water. It's required to have a fresh water less than 800 ppm in the fresh water. Or seawater. Seawaters, they roughly the salt concentration between 25 to 35,000 milligram per liter in seawater. Or brine. Brine is water with a salt. And why we need a salt in the water? To give it a weight. And I knew I went really fast yesterday to talk about completion fluid, but brine is the completion fluid. It's simply water has a density. So what is the advantage of the water-based mud? Water-based mud, it's used more in drilling, and the main thing about it, because it's much cheaper than oil-based mud. It's it's like a 1/10 of the oil-based mud when you use water-based mud. And it's much environmental friendly, because at the end it's water, it's not oil. It will not harm the environment. So it's economical and environmental friendly when you use water-based mud. So water in the past, it was water and bentonite. Maybe 50 years ago, when they drill with water, they add bentonite to add viscosity to it. So only water. But nowadays it has a very customized chemicals, very customized additive. They make it very inhibition. They try to reach the level of oil-based mud, and we know that the difference between these two is the ability to drill shale, reactive shale.
Actually, so there's no presentation on the screen.
Oh, okay. Thank you very much. Thank you very much. Can you all see it now?
Yes, it is clear now. Thank you.
You should guys told me, because this is like my 5th slides. Can you see now the presentation?
Yes, we can.
Yeah. Okay. Really quick, this is water-based mud. We'll talk about it more. So we have a fresh water and seawater and brine. We talked about the economical and environmental friendly alternative to oil-based mud, customized to the shale formation, minimizing the wellbore stability. As I was saying, that nowadays they're trying to really advance water-based to reach oil-based, and mainly because it's much economical and environmental friendly. But at the end, oil-based, you can drill any reactive shale, but with water-based, it has its own limitation. So we have here non-inhibited and inhibited water-based mud. And simply inhibited water-based mud, it's a water-based mud added to it chemical like polyamine and KCl that has to lower the water activity in the when it's touched the formation. So they are trying to increase its efficiency when it's drilling shale. This is means by inhibited mud. Non-inhibited, it's very simple mud. There is no inhibition to it, and usually inhibited mud, it's much expensive than non-inhibited mud. This is going to the details what chemical they use when they are using, for example, non-inhibited spud mud, polymer bentonite, extended bentonite. So it has a viscosity, and it has a so for example, spud mud, it has only the ability to carry cuttings, but does not support much of wellbore instability in case of filter cake. So, and you have now non-disperse inhibited systems, which is sodium ions, calcium ions, or lime. We go to non-disperse inhibited system. Disperse inhibited fluids attempts to combine disperse clays and defluctuating. What do you mean with disfluctuating if you study chemical engineering? So when we add, we call it in the mud industry, we call it thinners. When you add thinners, it's the opposite of adding viscosity to the system. So you will add viscifier to add a viscosity to the system, and you add the thinners to defluctuate the clays, and it reduce the rheology. So there are high performance water-based mud and conventional water-based systems. The main things about them, it's conventional, most commonly non-inhibited. So it does not have the inhibitions chemical to it, and it could be dispersed and non-dispersed as well. While high performance water-based mud, it has an inhibition to it, and it's more expensive to make, but it's much better, and it's better for the formation to drill it. The most common properties, because if you are at the rig site and you are working as a fluids engineer, you basically your job is to maintain the required parameters, and these parameters for oil-based mud and water-based mud are different in some of them, but they are same for the others. For the most important one, mud weight. And mud weight at the rig site, it's measured every 30 minutes. We have a person dedicated to it called the mud tester. He measures it every 30 minutes and check the mud weight, because increasing the mud weight, that means something. Decreasing the mud weight, that means something. If the mud weight goes up to required, you will have a problem. You will have a stuck, or you'll have or you will going to have a kick. So mud weight is the most important one, and everyone in the oil and gas industry knows mud weight. Mud weight is the most important one. Then the other parameters will come with the mud weight. So mud weight, it has to be checked every 30 minutes, and depends about the region. Some people, they do it with the BBG, some people do it with the SG, some do it KBA. So all the density reference. However, it's the main one. Then we will go to the rheology, and rheology, as we studied yesterday, it's the science of the flow materials, and it's rheology. So we have a person in the rig dedicated to measure mud weight and viscosity, but he usually does not have a degree, and he can do the mud weight, and there's a funnel called the funnel viscosity. He will he only going to get a reference number, how much the viscosity of the mud every 30 minutes, if it's increase or decrease. But if you want to get the correct data, it has to go through fluids engineer. He will get you the plastic viscosity and yield point and gel strength using an equipment called a viscifier. This is plastic viscosity, yield point. We as we discussed yesterday, it's yield point. It's the energy required to initiate the flow, and any difference between these two will tell the fluids engineer there is something, and it's required to be in a certain range. Higher yield point means it's going to have a higher bump pressure. It's going to create a problems. Lower, that's mean low well cleaning. This is very simple. And also water base has a solids analysis, same as a OBM, water oil based mud. Solid analysis will tell you about low gravity solids, high gravity solids. And if we talk about this subject, high gravity solids, the solids we add to the mud, which is like a barite, calcium carbonate. These give the mud weight. Low gravity is the cutting. You don't want it because it will damage the logging equipment, and it's not good for the cumulative cutting within the well. And you will have a filtrate ABI. There is ABI for the water-based mud to measure the, as I said, it's the filter cake for the well. It means you have a very good filter cake. That means you have a very good wall in your well. That will help your well does not collapse. There is two ways to measure it. ABI, which is you do 100 psi in the pressure, and there is high pressure, high temperature, and usually high pressure, high temperature used with the OBM. And ABI you cannot use OBM for ABI because OBM, it has a very high performance compared to water-based mud. And you have a CEC, and this is the measure how much clay within your mud. So a fluids engineer, he knows, for example, if the YB increases and you have a increased number of CEC, that's mean you're required to dump and add a fresh mud. This is one thing, but it's a test used in water-based mud, but does not do for the oil-based mud. And again, in water-based mud, you have a pH and alkalinity as well. And pH and alkalinity, basically, when you want to mix a fluid, water-based mud, you should have a medium. I give you a very simple example. If you want to make a tea with a milk powder and the water is contaminated or it's not clean, the powder will not mix in that water. However, if you have a fresh water, really clean water, and you add the powder in it, the milk powder, it will be mixed. Same thing when you have if you have a really bad low pH, the mud will not mix, it will not work. Same pH and calcium, these two things. So the mud has required certain pH, usually between 9.5 to 10.5, to keep it from not get rotten, because we use some chemicals are organic, and we know organic, like the food we eat, if you don't kill the bacteria and have the correct medium, the food will produce acid, and it will be damaged. So one thing is pH and one is alkalinity as well. And we have the filtrate analysis. What I mean about filtrate analysis, when you do your ABI, because you have a mud, you will have a brown color, has a solid. So when you do filtrate, it will come all water. That water, you do another test with it. You will do an alkalinity, BF and MF will give you these numbers will give you certain contamination, and you can do chloride and hardness as well. So chloride is the amount of chloride in the mud, and the hardness is the amount of the calcium and the magnesium in the mud. And high hardness, that means your mud, the fluids cannot be, the additive in the fluids cannot be working very efficient if the hardness is very high. So here the additive used in the fluids, weight material, viscifier, filtration control material, rheology control, loose circulation material. I think one of the guys asked me yesterday about how we can treat the theft zone. بالعربي المنطقة الهشة. واحدة من الأشياء اللي هن LCM loose circulation material, service additive agent, lubrication fluctuatant, sales special. I think this is a whole of for information you can guys process. So I'm not gonna talk about each one of them, because each one of them required a 30 minutes or an hour to talk about. But the main one is the mud weight material and the viscifiers. So like for example, biocides, these are chemical kills the bacteria in the mud. As I said, it's most of the additives are organic. So the first one is weighting material. Weighting material is the material used to increase the mud weight. Very simple. So usually if you mix fresh water, the fresh water is 1 SG. I don't know in Iraq what unit you guys use in the oil and gas companies, but here in Oman, with the main company called BDO, Petroleum Development Oman, they use KBA units, and we have a BB as well. They use BB. They use a pound per barrel. We have an Oxy. It's American. It's use again SG. So depends about the company what they use for weighting units. However, we use main companies use barite and calcium carbonate. Hematite is expensive and it has a very high specific gravity. Just more, I tell you something more. In the reservoir, we only use calcium carbonate because it's soluble. When you use acid, it will be soluble, but barite will not be soluble, but it has a higher specific gravity. Viscifiers, it's to remove cutting, and it's clay like a bentonite or a polymer used to as a viscifier, and very simple. When you use it for the water, it's increase the viscosity to the fluids. You have filtration material that's reduce the filtrate. You have rheology control. It's very similar to the viscifiers, and if you want to dispersion, they're called thinners, but it's expensive material, so they are not used only in the deep wells. You have a salinity and the pH control agent, magnesium oxide, or they call it caustic soda, calcium hydroxide. You have a potassium hydroxide, so you have OH ion to increase the alkalinity for it. You have lost circulation material, and this sometimes comes as a calcium carbonate with the different sizes. Service active agent, surfactant, it's a صابون باختصار بالعربي يعني. So sometimes you have a problem like a bit balling. If you guys experience drilling, bit balling, it's when you are drill and your bit covered with the clay, with the shale. So you have you spot this bill of soap, and then you increase the RPM, and the clay will go out of the bit. There's emulsifiers and wetting agents. These are used in OPM. You have lubrication. This is enhance the features of water-based mud. So it will help with the lowering the torque. Fluctuating, same thing. BHBA and bentonite extender. You have a shell stabilizer. So thinners and shell stabilizers are expensive chemicals because they are made in the lab. So shell stabilizers, polyamine, asphalt, potassium and calcium salts. So yes, these potassium and calcium salts, they are salts, but if you use a polyamine, it's an expensive chemical. You have a corrosion protection. These usually in the deep wells and used in the backer fluid because you will leave them in the casing. That's to remove the H2S, because one of the main reasons of corrosion for drill pipe and casing as well. Biocides, they used to kill a bacteria. So, for example, if you are drilling and you have a problem and you're going to pull out of the well for 2-3 days, the mud will get rotten. So you have to increase the pH and add biocide to kill the bacteria in the fluid. Daily, the fluids engineer submitted this report, and I put an example of this report So usually the fluid engineer do fluid check twice a day. I think it's very hard to read it, this one, but I think the next slide will tell you. However, you will have the bit information, the drill string information, the mud parameters, and the chemical inventory as well. So yeah, I think I have only this one. I have only this page. I will show you. So we'll tell you the time, the depth, the temperature. So you have the mud weight. You will have the BV and the YB. You have the gel. You will have the reading of 600, 300. If you have ever used the viscometer, I think in the subject called fluid dynamics in back in the university, I learned about the viscometer. So you read the 300, 600, 300, 200, 100, 3 and 6. This is the reading for rheology. And if you have a oil-based mud, if you have an oil-based mud, you will have an oil-water ratio, because it's not 100% oil. There's a water in it, because it will decrease the cost of it. So you'll have this ratio, and you have other parameters as well. You will have a low gravity and high gravity as well in the mud. And this is the products, depends about the company you are working on. This is an example for all the. So usually the fluids engineer, he has a variety of products in the chemical yard, and each chemical has its own function, and every section you will have this bill for the price of each section used in drilling. Thank you guys. I really enjoyed my time with you, and I hope you learned something new. I'm gonna just stop sharing my screen, and I'm very happy to answer any question you guys have. Is there
If
any
anyone
question?
has a question.
I guess nobody has a question. Thank
أستاذ
you all.
إبراهيم، شكرا
Yeah.
لك على هذه المحاضرة، جدا محاضرة ممتعة. نلتقي إن شاء الله في كورسات أخرى. بالنسبة لفورم A أحرص لبعد قليل في حال كانت عندكم بخصوص المحاضرة. أيضا هاي كانت نهاية محاضرتنا، وتصبحون على خير.